So now we're looking at the second free response question. So some boxes of a certain brand of cereal include a voucher for a free video rental inside the box. The company says that can be found in 20% of all the boxes. Based on their experience at home, a group of students believes the proportion of boxes with vouchers is less than 20%, so less than 0.2. The group of students purchased 65 boxes of cereal to investigate the company's claim. They found a total of 11 vouchers inside of these boxes, okay? Suppose it's reasonable to assume, okay, random sample. So anyway, this is our hypothesis test. So a couple of things I want to highlight really quickly. So just little bits of information that we're going to need as we go through this, okay? So we're checking for less than 20%. All right, that's one thing we're looking at. There are 65 boxes. They had 11 of the 65 found the voucher, okay? So step number one, all right, our null and alternate hypothesis, okay? So first off, this is a proportions question, okay? So we're going to say our null hypothesis is that the proportion does in fact equal 20%. Our alternate is going to be, we're checking for, is it less than? And then put it into context, okay? The proportion of cereal boxes with vouchers is less than 20%. All right, so we've stated our known alternate hypothesis. We've put the alternate into context. So now we're going to move on to actually doing this thing, okay? So next is assumptions and conditions, okay? All right, so for our assumptions and conditions, one, we have a random sample that is stated in the question. Second thing is that we want to make sure that our box of cereal is independent of the population. So for independence, we check is 10 times 65 is our sample size equals 650. So we're going to assume more than 650 total boxes. And lastly, to check for normality. So we have a population value of 0.2. So what we're going to do is that we're going to check 0.2 times 65 and then 0.8 times 65. All right. So just for fun. Point 0.2 times 65 is going to be 13. This is going to have to be 52 then. Since they're both greater than 10, distribution is approximately normal. All right, so if we're going through phantoms here, the P and the H we're taking care of in this first part. The A is right here. Now we have test name and important numbers. All right, so this is a one proportion z-test. Some people also call it a one sample z-test for proportions. Either one is acceptable. As far as numbers are concerned, okay? So we have a p-hat. All right, p-hat is our sample. So in their sample, they had 11 out of the 65. There's no mention in the question about a level of significance. So we can go ahead with 5%. We need to figure out our critical value. So this is a one-tailed test. We're only checking for less than. So if we look at our formula sheet here, we look for a tail value of 5%, which is right here. Go all the way to the bottom because that's the z-score. So our critical value is 1.645. So that's the number we have to beat. Now, it's a lower tail test. So it's actually negative 1.645 is the value that we're going to have to beat. All right. Another thing too, so our standard deviation, Once again, if you forget this on your test, if you go to your formula sheet, so this is this section right here. This is on, I believe, page 2 of your formula sheet. Okay. Either way, so for one population proportion, we just look over here and we can see that this is going to be our standard deviation, square root P1 minus P over N. So in this case, it's 0.2, 0.8 divided by 65. All right. So all that stuff is checked out. Let's go on. So name the test. All right. PHANTO, obtain test statistic, obtain p-value. All right. So now we're going to pull out our calculator. Okay. So you go stat test. This is a 1 prop z test. So our null hypothesis is 0.2. We had 11 out of 65. Down here, we're checking for less than. So our z-score is negative 0.62. Now, just a reminder of how that z-score is found. That's our standardized test statistic. It's this guy right here. Okay, so our z-score is, it's p hat minus p divided by, and our standard deviation we pulled a second ago, it's just p1 minus p over n. All right, and we found out that that's negative 0.62, which gives us a p-value of 0.267. Now, this next part you don't have to show on the test, but here's just kind of what happened, okay? So you have your normal curve right here. If this is proportion, so we had a sample of, or our population value is 0.2. Now our calculator gave us our p hat. Our p hat is 0.17-ish. All right. So our sample landed right here. Now, let's now incorporate the z-scores. We talked about a second ago, our critical value is negative 1.645. So we had to beat this value right here if we're going to reject the null hypothesis, okay? So this was our 5% tail. But with a z-score of negative 0.62, we didn't quite get there. This tail size, so if I'm looking at the entire tail size right here, and this is what our p-value is this tail size right here. Our p-value is 0.27 or 0.267. So basically what happened is that we don't have enough evidence to reject the claim, all right, to reject the null hypothesis, all right? So if I'm going to go ahead, now we're going to go ahead and do our conclusion. So this is your 3-sentence summary to wrap everything up, okay? So based on our z-score of negative 0.62, we fail to reject the null hypothesis. Second sentence, this is where we do the p-value and you put the null into context, okay? If there really were free movie vouchers in 20% of cereal boxes, we would get these results, or more extreme, 0.267 at a time. Remember to link this as well. This is greater than our alpha value of 0.05. There is not enough evidence to claim that less than 20% of cereal boxes have a voucher. And that's it. We're done.